Hey guys, this is module 1617 review, like an overview of everything we've been through. Circumference is 2 pi times the radius. Circumference is like perimeter for a shape. It's the distance around the circle. Since 2r is the diameter, we can replace 2r with d in the formula, so we end up with pi d. An example, when our radius is 5, 2 pi times our radius, 5, would give us 31.4 inches. You always want to include units in when you're working out problems that have units like inches, feet, meters. Now, area of a circle is a little different. We can think about these red wedges and blue wedges and rearrange them to create a rectangle. So the height of these wedges is the radius, which is r, and the whole distance around is 2 pi r. So if the blue ones and the red ones, there's an even number, half of 2 pi r is pi r. So when we multiply these together to get our area, we end up with pi r squared. So that's where that formula is coming from. Hopefully that makes more sense when you're trying to figure out the difference between circumference and area. Here's an example of area where the radius is 7 inches. You want to square that. 7 squared gives you 49. Multiply that by pi. And arc length is very similar to circumference, but we're looking for a specific piece of the circle. So theta is like our measurement. So you're going to replace that with m, or 60 in this case. And our radius is 9, so you'd plug that in. And that gives you the piece that you're looking for. I would suggest separating them and then multiplying them at the end. Now for area of a sector, it's very similar. You're looking for a piece of the area. So it's the area formula and the fraction of theta over 360. So in this example, we have 45 over 360. And then our radius is 6. Plug it in, use a calculator to clean it up. Now, equation of a circle, we have our HK and R is our radius. And this helps us find the equation of a circle. X minus h squared plus y minus k squared equals r squared. So here's an example of it being plugged in. When you plug in a -1, it's minus -1, so that's how you end up with y plus 1 squared. And here's an example of rearranging your x's and your y's together, completing the square by taking the b value, cutting it in half, and then squaring it. So half of 4 is 2, 2 squared is 4, so we're adding 4 to the x's. Half of -8 is -4, -4 squared is 16. So because you're adding 4 and 16 to the left side, you also have to add them to the right side. We end up with 36 on that side. We're able to factor, and that gives us our center and radius. So when you're converting degrees to radians or radians to degrees, it depends. If you're trying to go to radians, you want to cancel out the degrees, so the degrees will be on the bottom. And if you're trying to go to degrees and you want radians to be on the bottom so that they cancel out, it just depends on what you have. Pi equals 180, or you could use 2 pi and 360 here, depending on what you're comfortable with. In this example, 7 pi over 4, you could simplify the 180 and the 4 just to not have such a big number, but you can totally multiply across and type this into your calculator to give you the degree measurement. It's important that the pi is on the bottom, that way it cancels the pi on the top. So that's kind of how you know which form to use, either pi over 180 or 180 over pi degrees. Here, when you're trying to convert degrees to radians, your pi needs to be on top and your 180 needs to be on the bottom. That way that your degrees cancel. I like to write the degree symbol that way and cross them off so that I know I'm being left with radians. And with radians, remember to have pi on the bottom. That way it cancels. You can multiply across, and you guys notice how the pi's end up canceling, and you end up with 900 degrees for that one.